AFD block number 1, applied fluid dynamics. We're going to see a little bit on the mechanic energy equation. And as the name implies, mechanic means movement. We're going to talk about pressure, velocity, potential energy, which is essentially due to gravity and height, pumping system, and friction. We have many friction. Mechanic energy actually is also friction. And work going out of the system. So essentially is what we're going to see. Then we're going to apply this, probably you know the Bernoulli equation, and the Torricelli law. These are essentially sub-applications of this general concept. So let's do it. Let me show you the chapters that we're going to cover on this book and on this book right here. This is still not used. The Applied Fluid Dynamics book, we're going to see chapter number 6, which is fluid flow and the Bernoulli equation. The thing with Bernoulli equation is essentially that it does not cover pump and friction. Then we go and check out chapter number 7, which is the mechanical energy equation, which it does cover pumping and friction. Then for the unit operation of chemical engineering, written by McCabe and company, is essentially section number 2. It's called fluid dynamics, and we have chapter 4, which is basic equations of fluid flow, and more importantly chapter number 5, which is flow of incompressible fluids. So let me show you the detail block. Section 0, review. We're going to see a little bit on density, types of viscosities, what's friction, what's mass and the difference between mass and weight, the gravitational constant, which will be a pain in the ass for the English system, and for SI system actually you can actually ignore it because it's 1, so 1 times whatever number times 1 is the same number. A little bit on pressure, hydrostatic pressure, temperature systems, and so on. Then we check out section number 1, which is why do we use this famous equation, the mechanical energy equation. Please make a note here that I'm using MEE to abbreviate the mechanic energy equation. Types of systems that we will be modeling. Then we start analyzing each part on the mechanical energy equation, such as kinetic energy, potential energy. We see why do we have pressure head. Essentially pressure is force per unit area, and you know that if you move a force, then you have work. And work needs energy. And then we analyze the inlet and outlet work, especially how efficiencies are used, because when you have a system, you always have efficiency. For example, a work outlet, not all the mechanical energy transfers to electrical energy. And not all the electricity you use goes to work in a pump. Friction loss, the nature of friction loss, and it's the actual only value of all these kinetic energy that depends on the trajectory of the system. So that's a very interesting point right here. And once you get all these little concepts, we can actually start doing applications of the mechanical energy equations, such as Bernoulli law, the Torricelli's law, and in general the mechanic energy equation exercises, which include of course the pump and what else, the friction loss. So that was the overview. Next section will be section number 0. Thank you for watching and keep going. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you're, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.